Hello, everyone. I want to thank everyone for attending today's webinar, Charting the Path to RAN Virtualization, C-RAN, Fronthaul, and HetNets. This webinar is part of a program between RCR Wireless News and Monica Paolini from Senza Fili Consulting. Today's webinar will kind of cover the report that Monica just wrapped on charting the path to RAN virtualization, utilization of C-RAN, Fronthaul, and HetNets. Just a reminder to everyone in the audience that we will have a Q&A section at the end of the webinar, so please submit your questions during the webinar, and we'll get to them at the end of the webinar. Also, just a reminder that we will be emailing out a recording of this webinar, as well as a PDF of the slides to all of the panelists, or all of the audience members. With that, at this time, I'd like to hand the presentation over to Monica.
Well, Kat, thanks so much for the introduction. It's a pleasure to be presenting to you and talk about the findings from the latest report. It came out yesterday, so everything is pretty recent. You can download the report, and this is thanks to our sponsors, which are listed here. This is what we do with these reports. The reports are free, and the sponsors make it possible. And in the report, there are also interviews with the sponsors and with operators, and I will get to that later. So let me start and give you a little bit of background on the report and the webinar itself. And how I got into this. I was working on the report on NFV, which is also available, and it came out a few months ago. The main topic there was really the main focus was on the core, well, on the end-to-end network, but the core was the major focus. And as I was working on that, the issue of RAN virtualization became more and more interesting and more fascinating to me, and I thought that I would just work more on that. And the reason for that is that the general view is that you start with the virtualization of the core and then you move to the RAN. So it seemed like that's the most urgent part is the core. In reality, however, the virtualization of the core makes much more sense when you take the RAN into account as well. And what's happening on the RAN front, it's really fascinating. I would say that in a way it's even more fascinating than what happens in the core in many ways, because the core is a little bit closer to the IT world where everything is already been virtualized, so it's a little bit easier to grasp. What's happening in the RAN can be much more disruptive and much more interesting. So I'm very pleased to talk about this. It was great to work on this report, and today I will talk about what I found. And these are some of the topics that I'm going to cover today. What I'm trying to do is more to give you a sort of high-level view of the trends. So it's not so much a detailed report, but trying to understand what does virtualization of the RAN mean in the whole context of the evolution of mobile networks. One thing about virtualization in general and RAN virtualization specifically is that we're not introducing any new functionality per se. There is nothing really new. It's just that you do what we're trying to do already. You can do it better, or in a more cost-effective way. So it's not so much a question of in the same way that you would have, for instance, with LTE Advanced or 5G, of doing something completely new, but doing the same things in a different way. And that's that might seem like it's not as important, but I would say that in a way it's even more important because it makes you think of mobile networks in a different way. So it's a type of change that runs in parallel to the other innovation, and it's quite different but quite interesting. And towards the end, I will talk about a little bit about the introduce. So first of all, let's get started and look at where RAN virtualization fits in the big scheme of things. And so this is the graph here shows you the way I came to see about RAN virtualization, oftentimes the emphasis is on the cost saving. You know, Cloud RAN and RAN virtualization are going to be a more effective way to run the networks. Sure, I have no problem with the argument, perfectly fine. But if that's all there is to RAN virtualization, it would be a little bit disappointing. The really interesting part is the rest. And specifically is the fact that it allows you for a higher utilization of network resources. Now, that eventually translates into cost savings, of course. So the cost savings is always a crucial element in everything you do in a mobile network or in any for-profit type of activity. But it's not the immediate cost savings that you have from, say, using less energy or saving a little bit on hardware. It's really a cost saving that comes from rethinking and changing the way you run the network. So here, what I'm trying to get at with this graph is to, if we look at the networks, mobile networks, wireless networks today, we see on one side there is a huge growth in demand. There is more traffic, there are more devices and services out there, and we are only starting to scratch the surface on that. So the growth in demand is going to continue. It's not a short-term effect, as we know. But at the same time, you have capacity constraints because there might be a lot of demand, but it's very difficult for wireless networks to expand capacity to meet demand. It is difficult because you have spectrum limitation and funding limitations. So no matter how good the technology is, no matter how much advances you have there, there is just so much that you can do because subscribers are not willing to pay 10 times as much, and the spectrum is not going to change. So you can. There are some changes at the margin, but there is not. It's still a challenge. You're still dealing with a system that is constrained. So this is where virtualization in general and RAN virtualization comes in terms of working across all these different ways to improve networks, which are having new spectrum, new technologies, and densifying the infrastructure. The virtualization comes in and makes those efforts much more efficient. And that's what I was going back to what I was saying before. We're not doing anything new. We're doing things better. It is quite important because what that allows you is to get the investment you put into those areas to a better use. So in this respect, when you think about it in these terms, the cost savings, yes, they're important, but really what is going to be crucial is the changes in the long term in the terms of network resource utilization, which again is going to eventually come back and be a cost saving, but not necessarily in the short term. So operators need to adopt a longer term view, and the RAN virtualization has a potential to be a paradigm shift. But at the same time, if it's only a niche solution, well, then it's not really all that interesting. So let's go and move on and start digging a little bit deeper. So what is C-RAN? What I realized right away is that as I was talking to different players, everybody seemed to have a very different idea of what a C-RAN is, and clearly in a C-RAN you need to have the baseband processing to be in a remote location. But how remote is that? Do you need it to be pooled? Do you need to be virtualized? Is the focus more on the centralized aspect, on the collaborative aspect? So the C in the C-RAN can mean different things. This is China Mobile's 4 concepts, but there are many people have different opinions on this. so you can focus the fact that everything is centralized in a separate location, big data center, or that collaborative RAN allows you to improve the management of interference, traffic management, or mobility management. Or you can have focus on the cloud RAN, the sort of the IT aspects of it, or the clean RAN, which is the lower power consumption. In the report, the way I decided to look at it is to have a sort of an inclusive view of what C-RAN means. And so basically, the only requirement is that there is remote baseband processing. And the reason for that is because what that does is captures the richness of C-RAN. And I think that sort of goes along with the same type of trend that you see with virtualization. Virtualization gives you freedom, and freedom gives you different choices. So what that means is that we don't have a single path; we have multiple paths, and that's really quite important to leverage and learn from that. Use that freedom to learn about what's possible and what's effective. We don't know that yet. And that's what operators and vendors are trying to find out with the trials right now. So first of all, what is distributed RAN and what is C-RAN and virtualized RAN? So here it's a sort of a simplified view, if you wish, in terms of trying to get sort of the really generic view, and then we'll see how that it's going to be a little bit more complicated than this. But basically, we're moving from a traditional base station architecture where there is a single unit which is doing all the processing, and the first step towards a C-RAN is with the remote radio head, where you had the radio head separate for the baseband unit. And this is pretty common today, and it works pretty well. But all the baseband processing is still at the site, at the base station site. With C-RAN, we're moving that, so we moved to a remote processing, baseband processing, but at the same time, you're less committed to having it pooled, to have it virtualized, to use general purpose hardware. That's what's happening with the vRAN. And the vRAN is the next stage where you move towards more virtualization, general purpose hardware, although there is a question whether you might still want to have some hardware that is specialized for some of the functions. And in terms of topology, you tend to move to a more, generally speaking, to a more centralized topology. However, I will see at the end that trend to centralized processing, it's not a single, it's not just trying to get bigger and bigger locations or more and more cell sites combined. In some cases, you might move to a more distributed, back to a little bit more distributed approach, and we'll get to that later. So what is emerging is that when you are in the C-RAN stage, which is what we are getting into today, you have different types of C-RAN, and they address different needs from the operator. So in a local C-RAN, for instance, which is one of the first ones to be deployed, because there is a real urgency there. You have the macro base station that, the baseband processing is located at the macro site still, but it includes the macro cell and all the small cells within the footprint. So this is something that it's quite urgent, because operators are facing the need to densify the infrastructure and to manage an infrastructure of small cells which use the same spectrum as the macro cell. And you need to coordinate transmission to manage interference. In a traditional architecture, that's very difficult to do. And you do need to have a C-RAN type of approach to increase the efficiency of interference management. So again, C-RAN here, what the C-RAN does is increase the utilization of network resources. It makes the same hardware that you have out there to perform better. And so this is quite important. I think that we'll see that it's a win-win situation, because C-RAN benefits small cells, and small cells are a driver for C-RAN. Here you see an illustration of how that works out. There is the macro cells, small cells, and all the processing is done there, so you can do a local coordination of transmission. Then the micro C-RAN can be either private or public, and those are typically indoor locations or venues. It's similar in a way to local C-RAN, but tends to be wider in scope. And DAS is an instance of that. DAS is the precursor to C-RAN, and so those are the types of C-RAN that are already commercially deployed. Then you go to the other types that are much wider. So you start seeing bigger data centers with a larger number of cells, and this is more typical at the beginning for greenfield deployments. But eventually, we will see more of those wide area C-RANs. And then the final one is the advanced C-RANs, and that this is the way DOCOMO calls them, but there have been many different operators that are also working on similar approaches, where you do have, show in the next slide, you have a macro cell with other cells, with small cells that use a different spectrum band. This is also something that an approach that can be used with technologies like LLA, LTE, the LTE unlicensed or license exempt, that uses the license exempt spectrum. And the advantage of this is that you avoid interference between macro cell and small cells. And what you can do is to coordinate the transmission between the traffic load between the two. So you can use one or the other depending on the real-time traffic conditions. And this is a quite interesting way to manage areas where you have a high traffic density, and you need to make sure you are able to manage mobility, manage traffic-intensive applications, and in an uneven and changing distribution in traffic patterns. This is something that it's quite important to remember. When you have a dense infrastructure, you are much more sensitive to where demand comes from. And where demand comes from changes throughout the day. So for instance, if you have rush hour, at rush hour everybody is outside the buildings trying to go back home. During the day, in between the rush hour periods, people tend to be more inside the buildings. So even within the same dense area, the macro might see the equal amount of traffic, but that traffic is coming from different places within the footprint. When you look at the small cell level, so it's important to start thinking about managing traffic at that sort of finer grain level. So let's look at what does that mean. So you have all these different types of C-RAN. So how does an operator chooses among them? And that's it's important to for operators to clearly pick the appropriate architecture, and there is no right or wrong solution here. It's a question of trying to assess what the needs are, and then decide what is the best course of action. Clearly, funding, cost savings are major issues, but it's also the strategy behind it, and also probably the most important issues is whether you're dealing with a greenfield deployment or a legacy network. In a greenfield deployment, it's easier to have a C-RAN approach because you start from scratch, so it's much more compelling. In a legacy network, you have to work a little bit harder to try to understand what's the best way to integrate C-RAN within the current infrastructure, which is why the local C-RAN and the micro C-RAN are attracting a lot of attention from mobile operators because they fit much more easily with the current infrastructure. They really naturally fit in and, in fact, enable deployments like small cell deployments and make them fit better. And the other issue is clearly the Fronthaul availability and cost, and I'm going to get to that in a second. And then, so all these constraints determine are useful to define the implementation options. So the first one is what location you have, macro site or data center, the functional split, and I'm going to get into that later. A distributed or centralized topology. Again, I'm going to get onto all of this basically topics later. Whether you can use specialized hardware or you can use general purpose hardware. If you do intra or intra, you'll be pulling it at the data center. How you manage spectrum, and also how you can use core functionality at the RAN sites. And I'm going to get again into that one later, if it's a public or private RAN, C-RAN or vRAN. So what that shows you is that yes, it's difficult to come up with a single concept of C-RAN because there are different ways to look at it, different reasons to deploy it, and different ways to do so. One thing to keep in mind that is C-RAN is really part of the NFV platform. It's one of the use cases. There are two proof of concepts, one with China Mobile and one with SK Telecom. And this is important because it provides a common platform for core and RAN. And this is important because you're going to have cost-saving synergies because you use the same framework. And again, perhaps even more importantly, you can start thinking about having working on network optimization on an end-to-end basis. So on one hand, the core becomes more distributed and the RAN becomes more centralized. And what that means is that the two get closer to each other, and that's quite interesting in terms of trying to move to a user-centric quality of experience focused when managing traffic. Okay, so let's talk about the Fronthaul challenge. And Fronthaul is really, every time we talk about C-RAN, everybody will come up. That's a topic that comes up all the time. And this is because C-RAN has very tough requirements for Fronthaul, both in terms of capacity, latency, reliability. So that really changes. Well, that really creates a big bottleneck, and the people that typically do not support C-RAN, that do not believe in C-RAN, it's because of the Fronthaul issues, because Fronthaul is not seen to be a feasible solution, especially as you move out of Asia. It turns out that even in Asia, even Asian operators do not have fiber to all their sites. So they're also looking at different solutions. So here, one thing to keep in mind is that, well, I think that the way to approach it is to say, okay, well, yes, Fronthaul is a major requirement, is a major challenge. How do we go about it? Instead of saying, well, because it's such a big challenge, let's forget about C-RAN. Because the advantages of C-RAN and RAN virtualization are such that warrant a focus and an effort in trying to address those limitations. And there are three ways to go, well, at least three ways to go about it. One is the compression of the Fronthaul signal. different transport alternatives, and functional splits. And I'll get to those now. So the Fronthaul alternatives, so the people that do not believe in that C-RAN will ever take off, it's because they basically assume that you're using dark fiber, and that's the best solution if you have it. So assuming an unlimited supply of dark fiber, you go with that, and there is no problem. Reality, however, will prove that that's not a feasible and scalable approach. So there are different ways and different technologies to make Fronthaul, the Fronthaul transport much more manageable. WDM is emerging as a way to go. Some operators started to indicate that this is basically a requirement. Also, Ethernet is becoming much more, there's much more interest in Ethernet because Ethernet-based solution allow you to leverage all the Ethernet ecosystem, and gives you a lot of flexibility. And last but not least is the wireless solutions that allow you, especially for small cell deployments, to get to the final it's not a final mile, the final fourth of a mile, really trying to get from fiber to the small cell, and that's really a crucial challenge because that's where typically it's more difficult to put fiber. It's expensive, takes a lot of time, and you might want to be able to add and move small cells, and so the fiber infrastructure, it's a little bit too rigid to be used in these use cases. This is the wireless solutions are going to be important. They're also important at a different level. If you have a footprint and only say half of your cell sites, half of your cells are on a C-RAN and the other half are on traditional base station architecture, then the advantages of C-RAN tend to disappear. So it's quite important that if you have small cells or plan to have small cells, you need to have a solution in which the C-RAN can include every cell you have in the footprint, because you want to do coordinated transmission. So you can still do C-RAN only with a part of the cells that you have in the footprint, but then the advantages tend to the performance advantages tend to disappear pretty quickly. Cost savings might still be there, but if you're looking at the performance advantages, you want to have all cells into the C-RAN. Functional splits, that's also another interesting way. And this is interesting because it really allows you to think of C-RAN as a set of very different type of architectures. So here, what we're showing on top is a situation where layer 1 functionality is in a virtual BBU pool, or at the centralized. I'm sorry, at the cell site. Why would you do that? What happens is that if you have layer 1 processing at the cell site, you have much less in a way of Fronthaul requirements. So this is a way to basically have the C-RAN, have a C-RAN architecture, but without having the requirement of a very demanding Fronthaul. Obviously, nothing comes for free, so if you do that, then you tend to have less in terms of performance advantages from the C-RAN. So there is no right or wrong solution here, depending on what you have, depending on what you're trying to do. You may want to go one way or another, but it's important to know that you have the flexibility. And here at the bottom, you can see the green arrows that indicate different parts where the functional split might take place. That's quite, that gives you a lot of flexibility in terms of the reduction of Fronthaul requirements. So in terms of capacity, if you go from an RF PHY split to a max PHY to max split, you might have 20 to 50 times less Fronthaul requirements in terms of capacity. So it's quite massive. And here there is two sort of special cases where one is at KDDI, where it's most of the processing is being done at the base station. However, a central scheduler allows you to run comp without having an ideal ideal Fronthaul backhaul. So so that there are ways to again, especially in the interim phases, to try to get as much performance improvement possible without having a fully remote baseband processing. The other one, it's from Docomo, which is basically the state advanced RAN, C-RAN infrastructure, where you do have this, the macro cells taking care of the control plan, and the small cells only doing the user plan data. So what that means is that you can coordinate better traffic in these environments. Okay, let's move on to the drivers for C-RAN adoption. Because so we saw what are some of the advantages, disadvantages, some of the options in deploying it, but why would you want to do it anyway? So first of all, there is there is indication from China Mobile and Orange here and other operators as well that there are definitely cost savings. So that's all very good. However, because there are so many different options and different ways to implement C-RAN and vRAN, that it's very difficult to generalize, to say what are the general cost savings, because depending on what you're trying to do, those numbers are going to be very different. They're also going to be very different depending on what your Fronthaul costs are, and they are very highly variable across markets and across operators. How you go, what kind of infrastructure operators have already in place. Now, I think that, as I said before, I'm much more interested in the performance improvements that you get from C-RAN. I think that those are much more interesting and much more, in the long term, brings you the real cost savings come from improving the performance of the assets you already have in the network. And here it's an example of the gain that you get from comp. You can implement comp without having a C-RAN. It's just less efficient. Now here, what you were seeing is from the proof of concept of China Mobile. You can see that there is a huge gain in performance if you have in a situation where you have comp and no comp in the C-RAN architecture, and so this is quite interesting, quite positive result, and this is where we're just learning that there is a lot of trial activity going on at this stage, and there are different ways, different tools to use. The other one is statistical multiplexing, and this graph shows you that if you have different cell sites, you tend to have a different temporal profile of traffic, and that really makes the use of resources inherently inefficient. So right now, the network utilization is something in the order of 20–35% of what's out there, and that's not because operators are not planning well for the networks. It's because of, as you see here, because the distribution of traffic changes through time. So if you're able to pull this traffic and use the same resources to manage the whole the whole set of sites, cells, you are able to be much more efficient in the way you use your resources. So one frequently cited case is where you have a residential versus business location. So in a business location, you tend to have more activity during the day. Residential, it's more in the evening. So if you can have a pooled BBU pool that allows you to manage everything in a unified, in the same location, that you can save on BBU resources. Another one is indoor versus outdoor. Sometimes during the day, people tend to be outdoors. As I mentioned before, during rush hour, people are outdoors. During the day, they are indoor in their offices, and so you want to be able to ideally capture this activity in the pool so that you can share it. Now let's go for the sort of more the sort of look at even further out in time. So what the C-RAN architecture is doing is basically challenging the whole question of individual cells. Individual cells as being the unit at which you manage traffic, the unit, the sort of the building blocks of a mobile network. So, for instance, if you have in C-RAN architecture, you must start wondering what is the difference between a small cell and a macro cell. They're just basically doing the same thing. It's and you're trying to coordinate transmission between the two, so they might have a different logical role, but it's basically the processing and the functionality. It is the same, and it's implemented in the same location. And what that does is to shift the focus from optimizing the network at the cell level to a network level optimization. And it's a transition between a cell-centric perspective to a user-centric perspective, where you try to maximize the user experience and try to get the network, the end-to-end network, to do whatever it takes to get that experience, to improve that experience. And this is quite important because ultimately, that's as an operator, that's what you want to do, to provide a better experience to the user, not necessarily increase the efficiency of the network. And what we're doing today is to try to maximize the efficiency of the network and hoping that that will translate into better user experience. But the two are not necessarily, or not always in line. So, for instance, you might have low latency in the network, but still have the user to have a bad experience. But in some cases, the latency might be a little bit higher, but still the user experience might be better. And here there are four different dimensions in which this is also, again, from China Mobile, that has thought a lot about the topics in terms of what does that mean. It's as a move to network level resource management, move beyond the cell physical ID, and you improve spectrum utilization, and you start decoupling signaling and data planes. And then there is another one that it's sort of a complementary to the sort of the death of the cell trend, is the fact that the distinction between core and run starts to disappear, because the core, as I said before, core moves towards the edge, run moves towards the center, and there is some room for some functions to happen at the same place. So, for instance, when you talk about real-time video content optimization or caching, it's moving towards the edge because latency is such an issue, and that you can minimize latency. So it makes sense to move some of the core functions towards in a more distributed function, and that gives operators the freedom from physical location, so they can decide whether they want to have their solution to be more centralized or less centralized. But what that means is that physical location becomes more important rather than less important in a virtualized world, which is somewhat counterintuitive because with virtualization you abstract from that, from the physical implementation, and yet what that gives you actually is the ability to leverage location to improve performance. And this is it from the report. So let's move to the interviews. And I have to say that when I read these reports, the interviews are the most fun part because and the parts where you really learn a lot. So take the time to read them because there is a lot that comes out in the interviews. We try to talk about the experience that vendors and operators have, and so try to go beyond the sort of the standard message and try to see what people are learning as they do go through trials and early deployments. So I'm going to go quickly through the interviews, and because I don't want to spoil them for you, I want you to read them. And so I'll go very quickly through them. Aravana talks about indoor C-RAN and how that optimizes small cell performance. This is the indoor part of C-RAN small cells, and generally speaking about the need to provide better indoor coverage. It's becoming really a top a top issue, concern, challenge, opportunity, you name it, because most of the time, most of the data traffic, so data traffic is 90% of traffic, and 80% of it is indoors. So you can see that most of what happens is from indoor locations. And so to have all the infrastructure to be located outdoors just doesn't seem quite right. So there is more and more an interest in moving infrastructure indoors. And as you do that, you don't run networks the same way you do. And Aravana is trying to address this market. Then with ASOCs, we go into more the sort of virtualization of the RAN. How is that going to pull together the need to increase the spectrum efficiency to get the RAN within the NFV platform, which, as we saw before, it's really quite crucial, and then how that allows you to centralize the RAN and work within a HetNet type of perspective, type of environment. And this is quite important. As I said, especially it is important in the long term. On day one, the solutions, the type of virtualization is going to progress gradually. So we're not going to have full commercial virtualization in 3 months from now, but it is important to focus on the big picture and on the important and the disruptive, the really innovative part of RAN virtualization, and this is as where ASICS is going. Then with Fujitsu, we talk here more about the Fronthaul challenge and how to address it, and on the need to think of Fronthaul not as one solution, CPRI over dark fiber, but to adopt a wider view to see what is available, what are the different possibilities there. Then Radisys. Here again, we talk about the evolution to C-RAN, how you're going to move from what we have today, from small cells, DAS, to a C-RAN architecture. What needs to happen? How can you have it happen? What kind of functional splits you can have? And finally, solid. We go back to the transport again. As you see, this is quite important, and to see how you can really use the Fronthaul as a challenge, take on the challenge, not just because you need to implement C-RAN or vRAN, but because you need to think about your networks in a different way. You need to think about wireless networks where you do have more we need to coordinate transmission, be more efficient, and to transport massive amount of traffic. And that's it from me. And I will not tell you much more about this, but there are also interviews with operators in the report, and I'd like to ask you to read them. And this is all from me at this point. So I think that I hope there are questions from the audience. And Kyle, what's going on?
Hi, Monica. Yeah, we've had a couple of questions come in from the audience. The first one, can you describe exactly the differences between Cloud RAN and Virtual RAN? Hey.
Yeah, so let me try to go back to, so there is, the difference is that a C-RAN is, a vRAN is an instance of a C-RAN. But a vRAN is sort of a more extreme, part. So you initially have in a C-RAN, you can have resources to be just remote but not pooled, not virtualized. So it's a sort of a broader concept that encompasses all sorts of remote location of BBUs. In a vRAN, you have general purpose hardware, at least for most of the functions, and pooled processing.
Great, thanks. Another question we had come in is, what is the impact of 5G and how does C-RAN play into that?
Well, 5G is, there's still some uncertainty of what it really is, but whatever it is, we will rely and have C-RAN, virtualized RAN as a main component. And so it is important today in the initial trials, initial commercial deployments, to keep in mind that that part of the evolution. And this is because in 5G you're going to have, for instance, huge things like carrier aggregation, coordinated processing, like with tools like COMP and similar, tools to be much more important. And those tools really benefit even more from baseband pooling. So this is going to be even more important rather than less important. And also there is a need to pull together in 5G different interfaces. Although obviously 5G is, you look at the future of new technologies, you also need to work with the existing ones, and so C-RAN, virtualized RAN, it's a good way to go. So it's going to be a fundamental part of 5G.
And another question, do you see C-RAN as kind of a competitor to outdoor DAS deployments, or can they be used somewhat in tandem?
Well, as I said, DAS is a form of C-RAN. So it's not, not only it's not competing, but it's really, it is actually the instance of virtual, C-RAN, that it's already commercially available, and it's actually a proof that when somebody tells me that they don't really believe in the C-RAN or virtualized RAN, that's a proof that it actually works. DAS is evolving more towards a broader, sort of like a sort of more cloud RAN type of solutions, but fundamentally it's the same because you have a remote baseband processing.
Another question we had come in is, how can an operator successfully migrate to C-RAN?
Well, that's a little bit of a challenge. So if you are an operator and you have a greenfield deployment, both the C-RAN, and the deployment is much easier because you start from scratch. You don't have to deal with the existing infrastructure, so that's easier. If you have a legacy network and you need to add the C-RAN, that requires a little bit more work. You can basically take the VBUs and put them in a remote location. But especially in the short term, then the cost savings are a little bit more difficult to justify. I mean, well, they're a little bit they're not as strong. So it is more of a challenge if you only look at the cost savings to do C-RAN in a legacy environment. However, if you have situations like the local C-RAN or the micro C-RAN where you have other deployments where you have to integrate small cells, new small cells, or you have indoor deployments, again, typically with small cells, or venue deployments. In those cases, it really makes sense because you can have your small cell infrastructure or indoor/small cell infrastructure to be part of a C-RAN, and what it's much easier to integrate. In fact, integrating the new small cells or indoor cells is going to be facilitated by C-RAN. So that's a case where the transition to C-RAN actually facilitates the overall new deployment rather than makes it harder. So this is a difference in that we're starting to see between Asia, where you have to have more of the sort of greenfield deployments, wide area deployments, versus Europe or US, where you might have initially more of those local C-RAN, micro C-RAN type of deployments, where you start at the beginning, at least, at the small level, and then widen eventually. So it really depends on what is it the operator is trying to do. But generally speaking, it is you have to be a little bit more careful if you have a legacy network, and that requires, and that explains why Europe and US have been a little bit slower to catch up on this, but eventually the advantages that you have in terms of performance, I think, will motivate operators to go through the transition.
We had another question come in. So, do you see any sort of limitations with using TDD technology with the C-RAN architecture?
To use what, sorry?
TDD.
No, it's well, it actually it's easier. Well, it simplifies the coexistence. So, generally speaking, when you have a virtualized infrastructure, you're able to integrate better multiple technologies. And so is TDD, as I mentioned, LTE unlicensed, 2G, 3G versus 2G, 3G, 4G, 5G, and also possibly Wi-Fi. And the reason why this is useful is because if you think about a situation in which cell sites might not your cells are not all co-located. You have much more flexibility in how you allocate traffic. Or right now we think about offload because there is the cellular network, or there is one network, and then you offload to a secondary network. So there's an implicit sense of hierarchy there. Within a C-RAN or virtualized RAN approach, you have different channels, different networks, or different cells that can be used for transmission, and depending on where you are, you may use one or the other. So the concept of offload, the way we have it today, that is from best to from first choice to second choice technology tends to disappear, and instead you see what are the available resources, what's the best way to use them. So it's a fundamentally a different approach that actually makes it easier to integrate TDD or other interfaces.
All right. Next question we had come in. So, in terms of statistical multiplexing, can you discuss the different areas there?
Yeah. So this is an area where we're likely to see more of an advantage in the longer term in terms of we're still learning. This is a new way to use BBU resources. But if you think about obviously one case is the residential versus business areas that I mentioned, but even within high traffic areas, there is a huge amount of uneven traffic distribution, and this is something that Japanese operators have looked into in some detail. So throughout the day or throughout the week, you have in the same in the same limited central area, you have big fluctuations in the usage, huge user distribution through time. So basically what that means is that people might be indoors during the day, outdoors at night. So you might want to have an outdoor small cell infrastructure when people are outdoors going home, and then turn on the indoor infrastructure where they are in buildings. And to some extent you can predict it and you can sort of plan it ahead of time, but there is a lot of variability that depends on things like weather, something that happens. So some of it is predictable, some of it is not predictable. So you need to be able to act in real time in terms of how you use those resources. And so that's a form of statistical multiplexing that is quite relevant because it really helps to use the resources more efficiently in areas of high traffic, which is where you need it, where it's more difficult to add capacity, where also subscribers value the service more. So it is not just that you have high traffic, you have high value traffic. So it's very important for operators to be able to to optimize resources as much as possible in those environments.
Great. We have time for just one more question. Is carrier aggregation helped by C-RAN?
Yes, and that's what I was sort of alluding before. You can integrate better different channels that you have. So you have a place where again you start managing resources more at the network level, not at the cell level. And what that does is that carrier aggregation can be done more effectively. So, for instance, in the case where you have, you might have a different frequency for different types of cells, you might want, or you might, as you go through spectrum refarming, you might want. You might have more flexibility. So this is all, this again facilitates the way you allocate traffic and manage resources. So you can do operators do carrier aggregations regardless of whether they have a C-RAN or V-RAN, but that supports them better.
All right, thanks, Monica. It's about all the time we have. I want to thank everyone for attending Charting the Path to RAN Virtualization, C-RAN, Fronthaul, and HetNets. Just a reminder, we will be sending out a link to the recording of this webinar as well as the slide presentation.